We've tackled a complicated subject in this module, so let's see if we can sum up. The raising of an exception interrupts normal program flow and transfers control to an exception handler. Exception handlers are defined using the try-except construct. Try blocks define a context in which exceptions can be detected. Corresponding except blocks define handlers for specific types of exceptions. Python uses exceptions pervasively, and many built-in language features depend on them. Except blocks can capture an exception object, which is often of a standard type, such as a value error, key error, or index error. Programmer errors, such as indentation error and syntax error, should not normally be handled. Exceptional conditions can be signaled using the raise keyword, which accepts a single parameter of an exception object. Raise without an argument within an except block re-raises the exception which is currently being processed. We tend not to routinely check for type errors. To do so would negate the flexibility afforded to us by Python's dynamic type system. Exception objects can be converted to strings using the stir constructor for the purposes of printing message payloads. The exceptions thrown by a function form part of its API and should be appropriately documented. When raising exceptions, prefer to use the most appropriate built-in exception type. Cleanup and restorative actions can be performed using the try finally construct, which may optionally be used in conjunction with except blocks. Along the way, we saw that the output of the print function can be directed to standard error using the optional file argument. Python supports the logical operators AND and OR for combining Boolean expressions. Return codes are too easily ignored. Platform-specific actions can be implemented using an easier-to-ask-forgiveness-than-permission approach facilitated by intercepting import errors and providing alternative implementations. Thanks for watching, and we'll see you in the next module.